say done. Okay. And now I'm about to share my screen. Okay, so let's see. Okay, this is a question that we are having, honorable members, which is related to a VPM. So vertical projectile motion, it has got questions in different styles, and it has got many different styles in which they can ask. They can give you a graph, they can give you a diagram representing could be the buildings, the object, it could be a tree or whatever. But in this case, for today's lesson, we're going to be looking at a situation where you are given a graph and they ask the questions based on the graph. So now, how we are going to be doing this question is by going through the given statement, looking at the diagram, and then going through the questions. If you guys have got any questions regarding how to approach certain questions, then you ask. Then last part, I'll give you guys a chance to work on them. And I might as well give you the final answers that you should work towards. Yes, okay. So let's see. A ball is dropped from a height of 2 meters and bounces a few times after landing on a cement floor. Ignore a friction. The position time graph below, which is not drawn to scale, represents the motion of the ball. So on the vertical axis, being the y-axis, you've got position. Obviously, you can see that line starts from 2 meters. So that means that ball was dropped from a 2-meter height. And then this is what happens, honorable members. Maybe let me quickly try to write that down. This is what happens. Imagine you having a tennis. You may have thrown it up and then it will hit the ground. After hitting the ground, it will obviously bounce back. And as it bounces back, it won't go back to its original height. It will definitely be below. And then still go back, but the height keeps on decreasing until it no longer bounces. You just need to be aware of something. Even though you might not be able to notice with your eyes, but as soon as the ball hits the ground, between when it hits and as it leaves, there's a time for that. So, for example, it might take 0.00 whatever seconds before it goes up after hitting. So that is why after hitting the ground, there is that small time before it bounces. Maximum height, hit the ground, and then from there, it bounces. You might not be able to notice while looking at it, but just be aware that for a bouncing object, it will hit the ground while it is in contact with the ground. It takes few seconds before it bounces. That is why that graph looks like that. And that is why also even on its way up, it doesn't reach that same height. Okay, maybe let me remove all of these. And then what I'm going to now do is to go through the questions where the first question, they want you to define the term free fall, I'm pretty much sure that by now you are able to define that term. And then on 3.2, they say use the graph and determine the following. The time that the ball is in contact with the floor before the first bounce. The time that the ball is in contact with the floor before the first bounce. Guys, do you understand what this question wants? Let me just check. Do you guys understand what this question wants? Atenda, Helri, Rufuno, Mita, Rufin. Do you guys understand what this question wants?
Sir?
Yes, Helri.
Isn't it not the time between 0.64 and 0.67?
Okay, then you've got an idea. Let me not say much, but leave it at that. 3.2.2, the time it takes the ball to reach its maximum height after the first bounce. Okay, there is another question. Do you guys have an idea of what that question wants? The question itself, does it make sense? Remember, guys, for now, I just want to make sure that you understand the question. Then I will then give you guys a chance to do the calculations and work on it and then submit once you are done. But for now, I want to understand. Do you guys understand the question itself? Guys, do you understand the question itself?
I believe so, sir.
Okay, then it's fine. 3.2.3, they're talking about the speed at which the ball leaves the floor after the first bounce. There's another question, honorable members. Is the question clear in terms of what they want? So it's like they want the initial velocity when it leaves that. So remember, at all the times you should be having three things. From what I can see there, I already have two. The height and also G, which is always 9.8. So there is that third thing that you will definitely need. Chances are high that it might be time. So that means you might need to work out the time when it reaches its maximum height. I was just giving a hint there. Okay, so now they are talking about time t, which is indicated on the graph. A tricky one, but I will guide you on that one. So time t, with regards to time t, I'm just trying to figure out if I can explain without straight away giving you the answer. Okay. Okay. So with regards to time t, this is how you can approach it. If you can know its V initial at that time. If you can know its V initial, or if you can know the time it takes to reach its maximum height, then you will obviously multiply that T for 2 so that you know the time it will take for it to hit the ground. Then that time you plus it with this time so that you have the time that takes you to that point T. So that obviously means your time will be bigger than that because you need to know what that time is.
Sir,
Yes.
may you please explain again? I don't understand.
Okay. So it's like they want the total time, but what I'm saying, Henry, is that if you can calculate the time it takes for it to reach that height of 1.2, can you understand this part, Henry, where I say if you can know that time, you will multiply
Yes, sir.
by 2 so that you know the total time it takes to get to there. Then you will add that time to this time. Let's say it takes 0.25. It means it will also take 0.25. That means the total time is, let's say, 0.5. Then you will plus it with that 1.97. So the sum will then give you the time at that point T. That's what they want. It's like they want the total time of that whole thing that happens on the graph. You just need to remember that there it's a V which can be taken as V final or V initial. It depends on how you approach it, but just remember it's 0. Just remember it's 0. It is dropped, okay, then it means it's 0. So you must just always remember that it is 3 things that you need. For example, Henry, you do have the height. You have that which you can take as V final, and then you also have 9.8. So already you have 3 things. Then if you have 3 things, how about you then calculate that time, and then you just multiply it by 2, and then you add it with that. Then it will give you the time at T. Does it make sense, Henry?
I understand the part where you say we about calculating the third dome's time. But then, sir, if we want to get the total time, shouldn't we be adding 0.64, 0.67, etc. until T to get the final time?
So you're asking why we are not saying 0.64 plus 0.67 plus 1.9 plus 1.97. Is that what you're asking, Henry?
Yes, sir.
So if you add those times, it wouldn't be practical. Maybe let's say, how am I going to explain this? It's like, okay, on your calculator, Henry, add all of those times together. I want to show you something. Add all of those times together, just like you are saying. So it's not necessarily about adding or having the total. We just want to know how long would it have taken for us to get to that time. So if you take this, you plus it with that, you plus it with that, you plus it with, you're going to have a bigger time, of which that bigger time, when you plus it with this one, it won't make sense that you will have such a big time in comparison to that one. Let's see this, you plus it with that.
I got 5,18.
Wait, how much did you get?
5,18.
5,
When I add all the time together, the
5,18.
given time. Yeah.
Okay, no, I see. Yeah, I never expected such a question, Henry, and I have to think of how to respond. But it's like you see, if we added all the times, it's like all of this happened within that 5,18. I'm not sure if you get me, Henry.
I do. I think my confusion is, I feel like if we calculate it, I'll understand as we calculate for the value. Maybe it will be easier that way.
Maybe, yeah, maybe, but yeah, something of that nature. I'm just saying, I'm trying to think of an example. You know, I'm actually trying to think of an example, but can I think of an example? Remember, guys, you can start in the meantime. So you can start, just make sure that you submit at 8 the latest. I'm not going to explain this. I'm trying. Yeah, I never expected that question, Henry. I never expected that question, but you definitely do not. It's like we're saying, okay, from 0, all of that happened and it took 1.97 for all of that to happen. Can you see, Henry? We're just saying for it to hit the ground and then bounce back, hit the ground again, and then before it bounces back, this is the time it took. It took 1.97 seconds. I'm not sure if you understand this part, Henry. So what we are now trying to figure out is that how long will it then take to make the last bounce? If it takes 0.5, then it means in total, it would have taken that 1.97 plus the 0.5, and then you know the total time it took to do all of that. But with us calculating that total, it doesn't necessarily mean that we'll need to add all of these times. We're just saying it took that long for everything else in between to happen. I'm still not yet convinced that this perhaps explains what you are asking, Henry. I think for now, I might as well give you guys an opportunity to work it out. And if you are still not able to notice it on your calculations, then when we do the corrections, it might make some sense. But let's see, Henry, are you now working on it? Guys, you working on it?
Yes, sir.
Okay. Atayanda, Rufuno, Mitano, Mfundo, and Rufin, are you guys working on it?
Yes, sir.
Okay. Okay. Just remember to take a screenshot just in case if I'm disconnected. But 9 o'clock. If I said 8 o'clock, I meant to say 9 o'clock, the latest. That's when you should submit.
Hayi. Semotweni kontatele mvuzo. Hayi ndizibhakele kusempini.
Guys, time to wrap up and submit. I did receive a, let's see this one. Okay, so I did receive your submissions, and let's see this one also. Okay, then it's fine. I'll just end for now, and I'll be checking your answer sheet.